Hi guys, I'm going to give it just a minute for people to take their seats, so to speak, and then we'll get started. Welcome to today's masterclass. My name is Lisa Richter and I will be your host today. Next slide, please, Emily. On the off chance that you don't know about CSIA, we are a global nonprofit trade association with over 500 member companies in 35 countries. For system integrator members, the CSIA Best Practices Manual and CSIA certification are some of the more popular member benefits, but you will also enjoy a variety of others, including professional development, learning from your peers, and access to professional services experts, including insurance, financial, and legal, who understand the SI's unique business needs. For partner members, CSIA offers an ecosystem to grow your SI programs, understand your customers' pain points, monitor industry trends, and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. In case you aren't a current member or haven't renewed your membership, now is a great time to join and renew. Membership provides you many benefits, including a full lineup of virtual events and other resources you and your entire team, from accounting to sales to operations, 365 days per year. Members can also take advantage of discounted registration rates for the in-person CSIA Executive Conference scheduled for June 27th and through the 30th in Denver, Colorado. At this time, I would like to introduce John and Win. Take it away, guys.
Thanks, Lisa. Win and I are excited to be here. We're also very excited to see everyone at the conference in Denver. So today we're going to talk about how to securely integrate IoT protocols, OPC, historians, databases, and remote data using the DataHub. If you attended a prior masterclass, we touched on this technology then, but since last October, there's been a variety of new capabilities that have been released. We really want to focus on this. But first, a word about the value of Software Toolbox to integrators. Software Toolbox brings together a variety of products, as you see here on the screen, with knowledge of how they work together in architectures using just our products, but more often than not, working with other companies' solutions, from small to enterprise applications, to provide a complete solution, and then backing that with a level of support that achieves very high customer satisfaction and net promoter ratings. The range of technologies is all through industrial automation software, very much focused, of course, on standards-based technologies, which is where integrators and users can obviously get the most leverage and scalability for their skills. So we have a lot to cover. I'm going to talk about the technology and some customer use cases first. Then in the second half, I'm going to hand things over to Win, and he'll be doing some live demonstration training with the DataHub, with MQTT and Historian. So the DataHub, we look at it as it's a piece of data integration middleware, and it has certain strengths I'm going to talk about on the next slide. But one of the things that it's very strong in is the ability to move data securely and to do so in ways that change the paradigm of accessing remote data, from opening the network and opening ports to moving data using proxies, DMZs, and doing things without opening firewall ports, and reversing which direction the data actually flows, but still achieving the desired end result of getting data from A to B or B to A or both. The tool, when you bring the data together, right, it has all these different connectors you see on the screen. Some of the more recent things we've added are some of the native historian connectors. And this is Software Toolbox for 16 years, has been supporting installations and integrators, pulling together all different types of data, unifying it into common data sets, and then securely moving it to where it needs to go. So let's look at the strengths. As I said before, secure data tunneling and mirroring. I'm going to show you some scenarios from simple to complex, but DataHub is a natural aggregator. And this is an important point. People sometimes think there's something special they have to do, but when you use any of the connectors that are part of the DataHub, as soon as you connect to that data source, select what you want, it becomes part of a data set that you define the structure of, and that data is automatically then available for use in any of the other connectors. It's also a natural OPC to MQTT gateway, and that's important because when people started using MQTT, there were a lot of applications where people putting together different applications and having to do a lot of configuration to move that data between these protocols, one industrial, one IoT. With the DataHub, because it's a natural aggregator, it's automatic. It's just there. Once you bring it in via MQTT, it's available to OPC and vice versa. Wynn's going to talk a little bit more, and I'm going to talk about recent support added for OPC alarms and events, but most importantly, UA alarms and conditions. The tool is also very strong at OPC Ua Certificate Management. If your engineers have ever done anything with OPC Ua, this is an important security capability in the standard, but it can be rather detail-oriented at getting it configured, and DataHub excels at making that easy for the user. And then performance and scalability. There's applications with DataHub with over 1 million tags moving through them. The speeds can add up to tens of thousands of tags moved through DataHub with latencies added by the DataHub that are in the milliseconds. Typically, the latencies over your networks are going to be more than what the DataHub adds as it moves the data through. So let's look a little more at aggregation. One application is to aggregate multiple OPC servers, tunnel that data securely between operating systems through firewalls across networks, and then feed that data to a single OPC client. Well, we can reverse that thinking and aggregate data from multiple OPC clients back to one OPC server. We can do similar things using OPC alarms and events, and now also OPC Ua alarms and conditions, which is the newer OPC Ua standard for this type of data. As I said earlier, DataHub connects to OPC Data Access. This is the standard that's been around since 1995. This is a standard that when we founded Software Toolbox, we were betting that this standard would be what allowed us to all have best of breed applications. And it's accomplished that. I think every SI we've ever met, you've probably used OPC DA. Well, one of the important things about a standard is that although there's certification for OPC products, there's things in every specification I've ever seen that are open to interpretation. But as you can see over here at the right, the DataHub has a lot of options to deal with the varying ways different vendors have interpreted the OPC DA specification. This allows us to work well and play well with our own OPC servers, as you'd expect, but really any other OPC DA server, and including popular names you see here. Integrating with databases, not just logging data, but also extracting data. And once that data is in DataHub, automatically exposing it via OPC Ua, or sourcing data from OPC Ua or DA, or alarms and events, or alarms and condition, and pushing it into popular databases. An example application of that is at Namibia Brewing, where they integrated some SQL Server backend, a DCS, SAP, Wonderware Historian using Top Server and DataHub. This is one it's on our website. It's a really interesting story because it's one of the driest places on Earth, and one of the largest components of beer is water. Well, they've done a fabulous job with their sustainability, their power sourcing from solar, biomass, and the way they manage all of that to be one of the fastest growing breweries in the Southern African region. Another application, this is one that Wynn worked on, was with Air Liquide involving air gas separation units and using modular process automation to reduce startup time by over 50% And rather than do that with custom code, they'd use DataHub's ability to connect to OPC DA servers, UA clients, convert those protocols, do bridging of the data conditionally, and even use a little bit of scripting to provide some very specific customized type of functionality, yet avoid writing a completely custom application to integrate between these DCSs and the various hardware. Speaking of OPC Ua, just as I mentioned earlier, one of the things that was done in DataHub was a big focus on making it easy. This connection test you see here lets the integrator, when they're configuring that OPC Ua client or server connection, see where the steps that happen in the connection. And if one of those doesn't work, provide messages to help troubleshoot and manage those connections and get them working well. Mentioned earlier the new capabilities involving UA alarm and conditions. OPC alarms and events has been around since the early days of OPC. Still a lot of it out there. It's found in a lot of DCS systems. The world's moving to OPC Ua alarms and conditions. OPC Ua, you probably all know this, but it has the advantage of its transport over a network is a single port, which makes it very friendly and easier to move through firewalls, though there's plenty of reasons to still use DataHub tunneling, particularly the ability that we'll talk about with security in a moment. But with the adding of this capability, we can now aggregate, log, and securely tunnel any type of alarm data using either one of the standards and convert between them. And we actually have a case that Wynn's been working with several system integrators, because it's 20 fuel terminals throughout the US and Canada, with the European headquarters roll-up of data to an Emerson plant web inmation system. There are multiple SIs involved because of the regional locations. And you can see there's a wide range of applications here. A lot of the sites have Allen Bradley Rockwell PLCs, but some sites had Omron and a few others. There's a Varic Fuels Manager application. We aggregate the data in top server. They actually configure the alarm generation in top server based off of the points pulled from these systems, feed that up via OPC A&E to DataHub, which then converts it to UA ANC for the central aggregation and roll-up. And OPC Ua real-time data is also passed directly to the Emerson system. So this was a great opportunity for SIs because their role was identifying data sources, configuring our products, collaborating with the end users Emerson team to do that integration, validating the data, and commissioning. So it's the type of application that when you look at how this might have been done without a product like DataHub, it would have been a lot more pieces of software, and it would have potentially been custom code. In this case, we had off-the-shelf products doing this. Another one of the new capabilities is the ability to directly integrate with historians. Before version 10 of DataHub, we would integrate with historians using, like an ODBC interface. Well, we now have native interfaces to Aviva Historian and Insight, OSI Pi, InfluxDB, Amazon Kinesis, and through a RESTful interface, really pretty much anything. It's store and forward capable with some really high performance capabilities. Those do vary based on the destination. We can move the data fast, but if the destination can only receive it so fast, well, that limits it. And you can combine this ability, which we hint at in this diagram here, where you see we have a DMZ and a receiver and some arrows that only go one way, indicating the type of applications we can do with tunneling architectures. And I'm going to talk about those next before we get down to Wynn's demo. I did put this QR code on here. You can pop your phone, take real quick if you want to learn more about these connections in depth. So tunneling is the idea of moving data across a network. Firewalls, routers, DMZs, proxies. In its simplest form, in the OPC DA days, this was DCOM replacement. We still do a lot of this, though a lot of architectures are moving to OPC Ua, where you have OPC DA clients, a network, and you use DataHub to tunnel the data between them. You can also tunnel and convert at the same time from DA to UA if you wanted to. And then once that data is in the DataHub, you can send it to any of the other connectors, but you can also tunnel data like Modbus, SQL databases, anything you can get in DataHub, including that alarm and events data. Important thing about the DataHub tunneling is that it never blocks or drops the local connection. So the OPC clients and servers think they're talking to a local connection. The DataHub focuses on quickly keeping that data updated between them, detecting network break in milliseconds. How fast is really up to you, how you configure it based on your network and how reliable it is. Then it can automatically recover those connections smoothly. So what happens is OPC client is sitting over here, server's over here, they're talking to the data hubs, connection goes down, the client, the OPC client gets told, hey, this data quality is bad, the connection's down. Then the data hub sits and retries at a frequency you define based on your network topology, resiliency, speed, etc. And it'll automatically recover and put that quality back to good. This is unique with DataHub. Other tunneling solutions tunnel the entire OPC command, which adds additional bandwidth, overhead, and also makes this recovery challenging. Because we're just moving data, this reduces the overall network bandwidth, but it also reduces licensing cost for some systems. We've run into systems where they charge based on the number of OPC clients connected. Well, by combining the DataHub natural aggregation ability with the tunneling, they can reduce that to a single connection. All right, so the other thing is that since we're just tunneling the network data, we're not exposing the network. We're not opening up. You know, when people talk about VPNs, one of the things to realize about a VPN is that as soon as you take a device and connect it to the VPN, you have now exposed that device to your entire network. And if that device is compromised in any way, applications on that device now have access to your entire network. So, you know, although we all use them, we're not a real big advocate of VPNs when it comes to industrial data security, when there are alternatives to do things through proxies and DMZs. For example, here's an example where we have an OPC server on the left connected to a data hub with a firewall and a tunnel. The data user or consumer is over here with the data hub. And you notice the connections. The source has connected out through its firewall over here to the client. You notice that arrow is not going back in. We've not opened any firewall ports here. So that the OPC data, the integrator configures this side and pushes the data out up to the data hub, and the client then receives it. Okay, well, now what if you don't want to have any firewall ports open on this side, over on the data user side? On the data user side, you can do the same thing by putting a data hub in the DMZ. Now, of course, the machine in the DMZ has to have open ports, but your IT professionals will tell you by definition that's the point. You know, this is the machine where you're putting your risk, but you're keeping this network isolated and the data source network isolated. So the client and the server connect into that, push their data down in, and the exchanges happen in the data hub. But you've probably noticed with these that the data flow is all one way. But what if we want to reverse that? Well, you can still use that same architecture by configuring the data hubs at each end to allow data to come back down that same tunnel. So what's happened is you haven't opened any ports at the source or destination. This works just like your web browser. You don't have to have an inbound firewall port open to get data back in your browser. You reach out, ask for it, and it comes back in over that same connection. This is using that same concept and technology to provide that bi-directional support in a much more secure way that is very IT friendly. Okay, so continuing on with this, if you can get it into DataHub and type of thinking and methodology that we always talk about is you can use the IoT gateway to convert anything OPC to MQTT and then move it to various different cloud connections. First, we're going to talk about MQTT Client, then Broker, and then it'll be Wynn's turn to show you this in action. With the DataHub MQTT Client, it can take OPC Ua data, DA data, Modbus data, Excel spreadsheet data, database, historian data, and publish that data out to MQTT brokers. It can do it via plain text or SSL. It can subscribe and has an advanced JSON parser built into it. It can use the Sparkplug B protocol, and it can act as a primary application, non-primary application, or edge of network device. This is a lot more flexible than just run-of-the-mill MQTT clients. It supports store and forward capabilities, as well as your last will and testament capabilities and QoS functionality, which you would expect from a broker. But the key here is that automatic conversion of data. If you subscribe with an MQTT client to a broker and receive some data, it's in the DataHub data set. It's automatically available via OPC Ua or DA, or can be logged to a database or historian. It's all you have to do is go configure those connections to say, log it, store it. The OPC Ua, you just have to turn it on. It's there, it's available. Connect with your client and get the data. A lot of details in the configuration. I'm not going to go through those. Wynn's going to go through some of them. But one of the things I like to show folks is that you have your standard MQTT connections, but you notice these tabs up here at the top. These tabs are specialized connections for Azure, Amazon, and Google. Now, if your engineers or you have ever tried to connect to these, they all are using MQTT, but they all have their own settings. They all have their own security and authentication. If you're using a generic MQTT client, you have to figure out how to map that MQTT client to the terminology and information in Amazon, Azure, and Google. If you're using DataHub, you go to the correct tab and everything's named the same. So it significantly reduces configuration time so your engineers can spend more time on the value-added efforts of where is the data at the customer site, where does it need to go, validating that data, designing the architectures versus fighting product configuration. So we all love MQTT. Slow bandwidth, I don't need to tell you how great it is. And I'm not here to cast aspersions on it either, but as an engineer, I'm not being responsible if I don't talk about some of the challenges that are out there. MQTT is a messaging protocol. By that, I mean it's an envelope. The MQTT standard does not define how you organize the sheets of paper and the information on those sheets of paper in the envelope. There's no standard data structure, which means your MQTT client broker have to be able to deal with parsing what could be very different data structures for different devices, different brokers. Brokers typically are not data aware either. They just moved the data. They don't have any ability to inspect the data, to make intelligent decisions based off that data, to feed data to one place or another based on the structure of it. You can also have problems with messages getting out of order. For example, if you have a high-speed MQTT device publishing data quickly, and it's going over perhaps a cellular network, you could have a message get delayed, and another message arrive at the broker before the first message. And when that happens, brokers don't sort that out based on timestamps. They just relay it on, which in a control system, having data arrive out of order could cause bad decisions to be made. It's something you actually have to be concerned about. And you may not realize with just an off-the-shelf broker that can happen. Also, in complex SCADA architectures, if you have multiple MQTT brokers, there's all sorts of challenges you can run into with the quality of service information, depending on how that's configured, and the reliability of that chaining of one broker passing information to another, There's also no security, no ability to restrict that data to read only. Your edge of network devices don't know if messages are received. And you typically get into multiple applications when you start doing conversion. That's why when DataHub came out with these new capabilities in V10, one of the goals was to address these things to help integrators and their users take their use of MQTT, no matter what SCADA system they're using that supports MQTT, to the next level. I'm going to sound like a broken record, but this is a point people often miss with DataHub, no matter how many times I say it. It's instant conversion, not just from MQTT to OPC DA or UA, but to any of the different types of connectors that DataHub supports, including your own. There's a .NET API if you wanted to write your own. People ask, well, how are you doing that? I said, well, that's the secret sauce of DataHub. That's the value in there, is it is able to do that and do that at high speed. So if you want to learn more about these challenges with MQTT, I could go on the rest of this session about it, but I need to get over to Win very soon so he can show you all this. We do have the ability to do a deep dive on this, a lunch and learn, breakfast and learn. We do have some videos we could share also if we've sparked your interest of these things you may not have realized about MQTT. But first, let's talk about how a DataHub solves it. Got a couple of reference or example architectures up here, one with a SCADA client via OPC Ua, one via SCADA where it is the MQTT primary application, and you have some MQTT client or edge of network device. Well, the DataHub is data aware. When you configure it, you can go in and do things so that you can route to non-MQTT systems intelligently based off your config. It's able to respond and handle and propagate errors and manage delivery and startup order issues. It can handle failed writes. Nodes, your MQTT clients, because at the point level, DataHub is paying attention to that data quality and that information is all propagated, your SCADA system can be much more aware of that data and its quality and whether they should trust it than if you just used a generic, sometimes free broker. The DataHub broker can also let you mark things as read-only. You're in control of security. And if you can imagine getting that data into DataHub, combining it with that advanced tunneling with a DMZ, no inbound firewall ports, you can really tighten things up while not slowing things down. The DataHub is also able to maintain that message order. As I mentioned earlier, that connection and status quality is automatically available to all users. So I'm going to look at a couple use cases and then off to Win. So the first use case, this is one where a client needed to move data securely from an Aviva system platform Galaxy, but also push data to IoT cloud platforms. So what happens is the system platform as an MQTT client delivers the data out to the DataHub MQTT broker with some redundant connections in there. DataHub can then deliver it to the MES and plant historian using industrial protocols like OPC, then tunnel the data over to an admin network where it then gets pushed via MQTT to IoT platforms, including Azure. Another application, customer had field devices using MQTT that had over 300 different point definitions. They're already getting their PLC data in via OPC to Pi, but they also needed to bring that OPC data together with the MQTT data, create some data structures, and feed that up via OPC to Pi. They were to do that using the DataHub's broker. The DataHub's advanced JSON parser allow them to create configurations of the field devices that can easily evolve through field device firmware changes, replacement, etc., that they could not do if they were using a separate broker and OPC tool. With DataHub, they do all that in one. So with that, I'm going to turn things over to Win, and he's going to spend the rest of our time together showing you some of these technologies in action. At the end, we'll have our contact info, and if you want to learn more, we can set up lunch and learns, one-on-ones, etc. So take it away, Win.
Thanks, John. Appreciate it. just confirm you see my slide with the hands-on time. Great, perfect, thank you. Let me pull up my live demo here and walk through that with everybody. We're going to bounce around in the live demo today. The goal is to cover most of the new features in version 10. So that will include the Sparkplug B broker. We're going to do some historian, both logging to a historian and then reading back from that historian. Then we can, since we can read from a historian, we expose that data over OPC HDA, in this case, OPC Ua HDA. So I'll show you how that's done. And then finally, what we'll do is do some OPC alarms and events conversion to OPC Ua A and C. So let's get started with the broker side of things. You know, to enable DataHub as a broker, it's a simple checkbox. We're going to use the default plain text port 1883. And the big part of this configuration is the message content. So we can just route messages, but the power in the DataHub is to be able to interpret the messages as JSON. And we have both a simple formatting and an advanced formatting. So if I open up my parser here, the messages that I'm going to be getting from my MQTT clients are in the format of a value, a quality, a timestamp, and a sender ID. And we have some other options as well. And then if you had multiple points per message, you could have a message start, a point separator, and a message end, which then we could, be parsing multiple points per message. In this case, it's one message per data change. I'm going to place all of the data that I get into my data domain called MQTT. This is really just a grouping of data, and you'll see that when we open up the view data here. So here's my MQTT data domain. And simultaneously, we'll also be acting as a Sparkplug B broker, as well as an MQTT generic broker. So and my goal here in this example is to show you the difference between how regular MQTT acts versus how Sparkplug B acts when DataHub is the broker. So what I need to do here is enable my broker here on this other side, or excuse me, enable the client to start pushing to DataHub. And if we open up, I'll show you the connections first. So we can see we do have one client, and that client is my MQTT standard client that's connected to DataHub. I have two sets of data. I have a Sparkplug B section, which we'll look at in a second, and then I have these three sensor values that are changing quite rapidly. So this data is all coming from a standard MQTT device. And what I'm going to do now is just turn that device off briefly. What you can notice is all the data stopped moving, but we still have a good quality. And part of that is because MQTT doesn't have the same construct Sparkplug B has enabled in order to enable letting us know that the connection has been dropped. So let's look at how Sparkplug B reacts somewhat differently. So I'm going to enable that connection, and I'm going to browse down into my Sparkplug B section of data. We can see we have our data moving here as well. I'm going to just disable that briefly for us. We can see we immediately get a not connected quality. So this is the one advantage of using Sparkplug B, is we have the ability to not only do some other things like detect out of order messages or failed writes or mark things as read only, but just a simple thing as marking the data quality as not connected can help your SCADA system understand that this quality or this data may not be able to be, it may not be valid anymore. So let's turn this back on, click apply, perfect. So now that we have our data flowing again, my next goal is to go into the external historian and show you how to log that data. So I've created a connection, but I'm going to make one from scratch just to show you how it's done. So First, we need to pick our historian type. I'm going to use the Aviva historian type in this connection, but we do support Insight as well as OSI Pi, Amazon Kinesis, InfluxDB, and then RESTful historians as well. So if I choose Aviva historian, we can give this a name, demo. This is on my same computer. We're going to use the default port. The most important thing you need really is the username and password from your Aviva historian administrator. So I'll type in my username, type in my password. We could mark this as read only. We're obviously want to log to this, so we're not going to do that. There are different types of transmission. We're going to do the stream type, and then there are also different types of storage types. And for anyone familiar with Aviva Historian, these settings are mimicked from what you can set in the Historian when configuring tags. We do store and forward data in the event of a connection loss. And I mean, really the next step is to choose some points. So I'm going to go down to my Sparkplug B tags. I'm going to choose value 1, 2, and 3. You know, we can do some other things like point name replacements where we specify the pattern and then the replacement. This would be done through regular expressions to change the tag names before we historize them. And then the other way we use regular expressions is through when we select points. So we could add a pattern here and specify a regular expression. I'm going to paste in one that I've already created, which essentially says I can take anything, data from any data domain, and then DataHub has a semicolon, and then anything with the word sensor in it. So in this case, I would capture any tag that used the word sensor anywhere in the name. That's what that regular expression stands for here. And we have some more settings on data sampling, and that's about it. So at this point, I would click OK, but since I already have one running, I'm just going to show you this connection here. So if we scroll over here, we see that I am currently already logging data, and I am logging those same 3 sensor values that we looked at just a second ago. So let's okay there, and we're going to pull up the Aviva Historian trend view, and this is updating live with data. You can see we've been logging data all morning, and this just updated again with more data, just to show you that the data is making it to the historian. And here's the different tags we're logging over here to the left. And I'm not going to go any deeper into the trend view. This was really just to show you that, to prove that we are actually historizing this data into Aviva Historian. So let's minimize that. The next thing I'd like to do is make DataHub the, make DataHub read from Aviva Historian as a source. So we can either check this checkbox here and click apply, or we can just select from the drop down any of the historian connections we have, which in this case I have one. So I would select it, click apply. So now we're actually reading from the historian. Well, what can we do with that data? That's really what I want to show you next. So when DataHub reads from a historian, all that data is made available via OPC Ua over the historical data access profile. So what we need to consume this data is a OPC Ua historical data access client. In this case, I'm going to use the OPC Ua expert. There is one thing I need from DataHub before we go into Ua expert, and that is my endpoint. So if I copy my endpoint to a clipboard, in this case, I'm going to be connecting over the opc.tcp on port 51310. And then I have some other settings here, and all this will be part of my endpoint name. Now, there's really nothing else we need to do in the DataHub to accept insecure connections. There won't be any certificates to manage or anything like that. We're just going to make a simple connection with no security. So I can pull up my add server dialog. I'm going to paste in that endpoint that I've copied from the DataHub. Again, I'm using no security and an anonymous logon. I've now connected to my DataHub. The next step we need to do in the UA Expert is we need to add a historical trend view. This is the way we visualize view the historical information coming from a UA server. So let's dig into my historical values. I have value 1 through 3. I can pop these up here to the top. And let's see, what time is it? It's 11:40 my time. So let's do like 11:30 to 11:40 and update. You can see we did a query. We have about 4,500 values of the value 1, same with value 2, and value 3 is just a changing set point that changes the other 2. So we have a lot less values for that. If we actually look at the values for each, we can see here we have both a source timestamp, a server timestamp, and a value going back till the time that I specified in my query here. So this is how you could use the DataHub to query a historian and then expose that data to OPC Ua HDA clients who can then consume that data. All right, let's close this view here. And the last thing I want to show you, and I think we've got time for, is converting classic OPC A&E to OPC Ua alarms and conditions. So the first thing we need to do is create a connection to an OPC A&E server. So I'm going to add that connection. I have the top server, which is generating a couple alarms for me. And I'm going to put that data in the OPC AE data domain. This is important to know because we'll need this later to tell DataHub where our alarm information is to go find that for the ANC conversion. There's really nothing else we need to do in this setting. I mean, that we could filter based on certain things if we didn't want every alarm, but in this case, I want everything. So I'm going to click OK, and I will click Apply, and our status should go to running, which it did. If we view data and go into my OPC A&E section and go to the status, we can see here we have 2 alarms. Let's build this out a little bit. We have a high for ramp 1 and a low for the other one. And what you're seeing here in the value is an OPC A&E data structure, which has all the elements of an OPC alarms and events tag. Not very human readable, but that's okay. The A&E servers know how to read that, and DataHub knows how to convert this to OPC ANC, and that's what I'll kind of show you next. So let's close this, and we need to go to the UA section. Again, we're already acting as a server. There is one thing we need to do to enable ANC, and that's under the advanced section. If we go to the alarms and conditions, we simply enable this checkbox, and we choose which data domain has our alarm data. And that's it. Click OK, click Apply. And let's go back to the UA Expert. And this time, again, we need some OPC ANC client to consume the ANC data from the DataHub server. UA Expert's a great test tool to show that. So I'm going to click Add. I'm going to add an event view in this case. And what we want to do is find this server under our root. We drag server here into this top area, and we can see here we have some events occurring for both ramp 1, ramp 2. They're going in and out of state. Here's the in state and active. Here's the out of state and inactive. And we can see, if you were using some other alarming package, you can acknowledge an alarm or something like that. And you could do that from whatever alarming client you have. But this is really just to show you that DataHub can serve up alarms and conditions data to any OPC Ua ANC client. And with that, I've done everything I'd like to show everyone. So let me pull back up the presentation and we can let John finish here. I'll go to the next slide here, John. There you go.
Alrighty. Well, Wynn, thanks for that demo, and we'll see if there's some questions about that. But hopefully that allowed everybody to see the concept of once the data is in the DataHub, you can take it anywhere, do anything with it. Integrators always want to know how's the product licensed. The DataHub is typically sold using a perpetual license with support. Subscriptions are available. We have common feature packs that bundle together the different capabilities into sets that are frequently used. And then a la carte features can be added onto those or put together standalone to create any valid configuration. Now, the typical solutions, starting out with DataHub, like basic IoT gateway type solutions, are going to run $1,500 to $3,000. And as I said, we've got the solution packs for the most common use cases there. When you want to move on to the next slide, please. So if you want to know more about DataHub, Software Toolbox is a partner for DataHub. We've been a partner with the developer of this product, Skynet, since 2006. That's why starting off, I said we have 16 years experience supporting integrators and users implementing this product. You can go to our dedicated website for this. There's a QR code that'll take you there. You may want to subscribe to our blog. It's a good way to find out what's new, case studies. If you want to set up a one-to-one or group or private discussion on topics of your choice around this, I just saw my own spelling error there. Oops, I'm only human. Reach out to Wynn or I, and we'll be happy to help there. So with that, Wynn, I think we can move on to questions. I'm looking, there aren't any in Q&A or chat right now, but I had a couple as you presented. You talked about going from alarming events to alarming conditions. Can you go the other way? Can you convert a UA to a classic A&E?
Yeah, we actually I had a user last week ask me if we could do that, and it's very simple. It's a lot like what we did before, but DataHub can convert both ways from A&E to ANC or ANC to A&E.
What if we need, I've run into SCADA systems that don't support either of those standards, but they need some of the data, say out of a DCS that's acting as an A&E server. Can DataHub take apart those structures when it brings them in and expose that via DA or UA, just your classic data access methods?
Yeah, so what I showed was the pure A&E data structure, but DataHub has a simple checkbox option that if we enable it, we break apart that structure into its individual elements. So then you'll get a tag for things like the alarm state or the alarm text. And then all that data can then be used either by your HMI or SCADA for real-time access, or maybe you want to historize that to a database or historian or something like that that doesn't support the alarms and events or alarms and conditions interfaces.
Okay. And on the with the MQTT, how many clients can the DataHub broker support?
Yeah, we did some improvements in version 10 and have done testing with over 500 clients connected to DataHub. Now, of course, that may vary depending on how much data each client is sending, but we certainly have increased our ability to support a large number of clients in DataHub.
Yeah, we really appreciate what our partners at Skynet did to enhance these capabilities in this most current release around the scalability of MQTT, the Sparkplug B support, the native historians. So I think for our integrators out here on the call, it really opens up. DataHub's been around a long time and has solved tens of thousands of applications. That really opens up some new space here. So if the integrators want to learn more, but don't necessarily want a one-to-one session, do we have some training available for them?
Absolutely. Yeah, we have we have a video on almost every different feature in DataHub. If you go to the DataHub website, you'll find a link to our video library, and every video is somewhere between 5 and maybe 10 minutes long, should be nice and quick and easy to consume to figure out how to accomplish a specific task with DataHub. So.
Okay. All right. Well, we certainly don't have to stick around. We can give everybody 10 minutes back in their day. Lisa, I don't see any other questions. So if you want to do some wrap up, if anything pops up, then we'll answer it here quickly. But our contact info is out there if you think of anything.
Awesome. Thank you so much, guys. Emily's going to pop up our last few slides here for me. On behalf of CSIA, I would like to thank John and Wynn for this informative discussion. I would also like to thank Software Toolbox for sponsoring this event. And of course, thank you for attending. I'd also like to remind you that a recording will be available for viewing within the next couple of days. Be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. This concludes our program for today. Once again, thank you for joining us and have a great day.
Thanks, Lisa. Take care. Thanks, Wynn.
Thanks, everyone.
Bye.